Okay, so now we're going to get into chapter 2, which is about reasoning and proof in geometry. So we're going to talk about conditional statements. So you could make a conditional statement in geometry using if and then form. So today's goal or essential question is to recognize and analyze a conditional statement and also be able to write postulates about points and lines and planes using conditional statement. So any kind of statement you can convert or make it into a conditional statement by using the phrase if and then. So it has two parts to the conditional statement. It has hypothesis, which is the if part, and then a conclusion, which is the then part, right? So if and then form is what we use to write any kind of a conditional statement, right? So if part contains the hypothesis, as we mentioned already, the then part contains the conclusion, right? So again, hypothesis comes after the if, and the conclusion comes after the then. So I can make a conditional statement like this, right? If you are in Mr. Park's geometry class, then you are really smart. Is that a true statement or a false statement? Well, of course it's a true statement, right? If you're in Mr. Park's geometry class, then you are really smart. Of course you're all smart, right? So the if part is the hypothesis. So you are in Mr. Park's geometry class is the hypothesis. The conclusion is you are really smart, right? So that's the how you write a conditional statement using if and then. All right. So then what you do with the conditional statement is that you can switch the hypothesis and the conclusion. And when you do that, you get a converse of the original conditional statement. So the converse is switching the hypothesis and the conclusion. So instead of saying if you are in Mr. Park's geometry class, then you're really smart, that you would switch it. So the converse would be if you are really smart, then you are in Mr. Park's geometry class. You notice how the two parts are switched. So that's converse when you switch the two parts. Now, negation is just like the way it sounds. You're making it negative or you're making it opposite, right? So you're putting a not into the statement. So we call that inverse of the original conditional statement, where you put the not into the hypothesis as well as into the conclusion. So the if not A, then B for the statement that I made earlier would be if you are not in Mr. Park's geometry class, then you are not really smart. So that would be the inverse of the original conditional statement that I made. Right? Now, the contrapositive is doing both the converse and the inverse together. So you switch the hypothesis and the conclusion, and you also put a not in it, right? So you're doing both the converse and the inverse when you're doing the contrapositive, right? So the contrapositive of the original statement that I made would be if you are not really smart, then you are not in Mr. Park's geometry class. So that would be what we call contrapositive, right? So you can take any conditional statement, any statement using if and then, and you could make it a converse, you could make it an inverse, or you could make it a contrapositive, right? And so depending on how you write those four statements, we get what's called the equivalent statements, which means that they're going to be either both true or they're going to be either both false, right? So the two equivalent statements usually are paired up like this. So the original conditional statement and the contrapositive will be both true or both false. And then the inverse and the converse of the original conditional statement would be both true or both false. So that's what we mean by equivalent statements. So they kind of go together, whether it's true or false, right? The original statement and the contrapositive statements go together, whether they're true or false. And the inverse or the converse statement, they go together because that's what we call the equivalent statement. Okay. All right. So then let's take a look at some examples of how we use this. So first of all, we can write any statement like this, any sentence like this, and just put a if and then into the equation, right? So for example, here, 3 points are coplanar if they lie on the same plane, right? So you can convert that into an if and then statement. So the if is already here, you notice. So then you could just say if the points are on the same plane. So it says if the 3 points are on the same plane, then they are coplanar. So you can make any statement into what's called a conditional statement as long as you have the if and then phrase in the sentence, right? Same thing with the second one. Water freezes at temperatures below 32 degrees Fahrenheit. Now this one doesn't have if and then there at all. So you can put the if and then by making it kind of, same kind of a meaning here. So if the water freezes, then the temperature is below 32 degrees Fahrenheit. So you're just trying to make a logical statement by putting the if and then into the sentence here, right? So the last one here is an even number is divisible by 2. So then if you make that into a conditional statement by putting if and then, you could say if a number is even, then it is divisible by 2. So that's how you can write a conditional statement as long as you have if and then, if and then, if and then. That's what we call a conditional statement. So the first part, the if part, is the hypothesis. The then part, obviously, is the conclusion. All right. So you should be able to rewrite any sentence into a conditional statement. All you need to do is use if, then. All right. So then we could also switch the sentences into inverse, converse, and contrapositive. So if I have a original statement, this is the original conditional statement. If the sun is shining, then we are not watching TV. Now, be careful here. This one already has a not in there. So that's what's kind of tricky there. So I can put an inverse. So inverse meaning putting a not in it, right? Making it opposite. However, if it already has a not in it, then just take it out. So this will be if the sun is not shining, then we are watching TV. So let me show you that. So if the sun is not shining, then we are watching TV. So if there's a not there already, then just take that out for the inverse, right? Converse, all you do is switch the two parts, switch the hypothesis and the conclusion from the original statement, right? So then put this we are not watching TV in the front. So converse will be if we are not watching TV, then the sun is shining. So we're just switching the two parts, right? We're not putting a not in it or we're not taking that out. That's what we do for the inverse. Converse, we just take the original statement and we're just switching these two parts. The if and then just switches, right? So the hypothesis goes to the conclusion and the conclusion goes to the hypothesis. So that's converse. Now, contrapositive is doing both of these together at the same time. So you switch it and then you negate it. So then you switch it. So we're going to put if we are, but instead of not, we take that out. So if we are watching TV, then the sun is not shining. So we put a not if it's not there. If it's there, we take it out for the contrapositive, but we switch the two places. So contrapositive is doing both the converse and the inverse together at the same time. All right. So that's how you write a contrapositive. So it might sound kind of confusing now, but just remember that you're taking the original statement and you're just moving things around, and you're either putting a not in it, which is making it opposite or making it into a negation. If there's already a not in it, then you just don't put it. You just take it out, right? So you're making it opposite of what it's saying for the inverse. Okay. All right. Let's take a look at some more examples. So go ahead and take a look at this and pause it. Pause the video and see if you can write the inverse, converse, or and contrapositive of the original conditional statement. Okay, if my allowance increases, then I can save more money, right? That would be nice. Okay, so go ahead and pause it and see if you can write the inverse, converse, and contrapositive. All right, did you get it right? So the inverse is putting a not in it, right? So you put if my allowance does not increase, see how it's not in there? Then I cannot save more money. So inverse is putting a not in it. If there's a not in there already, you just take it out. You're just making the negation or the opposite of what it's saying. Right? Now, converse is switching the hypothesis and the conclusion. You just switch these two parts. That's all you're doing for the converse. So it just says, if I can save more money, then my allowance increases or increase. So you're just trying to make a sense out of that sentence. So that's converse, just switching the hypothesis and the conclusion, right? Now the contrapositive is doing both of these at the same time. So you switch it and then put a not in it. So you switch it. So if I cannot save more money, so it's I cannot save more money, then my allowance does not increase. So you notice we switched it and then we put a not into the sentence. So that's contrapositive. All right. So hopefully you got that right. All right. So you got the original statement, which we call conditional statement. You could put a not in it and make it into an inverse statement, or you can just switch the two sides and make it into a converse, or you could do both of those and make it contrapositive. All right. So you should be able to take any statement and be able to change it around like this. All right. All right, so then here are more postulates, which the Greeks thought was kind of obvious that you need to know going forward, right? So some of these should be obvious because we kind of already talked about it. Some of them may not, but it sometimes helps to kind of draw pictures to help you understand what's going on, right? So postulate number 5, through any 2 points, there exists exactly one line, right? So if you have any 2 points, right, you can draw one line through those 2 points. So if I have a point here and point here, right, through those 2 points, I can draw one line. Well, it's supposed to be straight, but yeah. And so that's the only line I can draw going through those 2 points, right? So that's what that is saying. Now, the postulate 6 is saying something similar to this, but saying it a little bit different way. It says a line contains at least 2 points. So we had 2 points right here, right? So that's what makes that line. But it's at least 2 points because there are infinitely many points along that line, right? So it's at least 2 points to make it a line, right? But there are just know that infinitely many points, right? Postulate 7, if 2 lines intersect, then the intersection is exactly 1 point. So we talked about this already many times. When 2 lines intersect, right? It intersects right there, and that's exactly 1 point, right? When 2 lines intersect, it's going to intersect at exactly 1 point, right? Postulate number 8, through any 3 non-collinear points, meaning not on the same line, there exists exactly 1 plane. So if you have a point here, right, and then you have another point that is not on the same line, right, there's one plane that's going to contain all three of those points, right? So there's exactly one plane that has three non-collinear points altogether, right? And then this is saying basically the same thing. A plane contains at least three non-collinear points. So a plane has three non-collinear points that are on the same point, on the same line, but there are infinitely many points on this plane. But it's at least three non-collinear points, right? So it has to be non-collinear, right? So not all three of them are on the same line. 2 points lie in a plane, then the line containing them lies in the plane as well. So if I just have 2 points like this, right, and then that is on this plane, right, well, then if I draw a line through those 2 points, well, that line is also on that same plane. It seems kind of obvious. That's why these are all postulate. Remember, postulates and axioms are something that's kind of obvious, right? So that is also on that plane. Now, postulate 11 may or may not be obvious to you, but if two planes intersect, then their intersection is a line. So this is kind of like the example of two planes intersecting. And so it's intersecting right here in the middle, and that right there is a line where the two planes intersect. So we talked about this before, where if you look at the wall in your room and the floor, look at where the wall and the floor meet, intersect, right? They intersect at the corner at the bottom, and it's a line, right? If you were to kind of imagine the room going forever, right? So that's what this means. Two planes intersect and form a line. Okay, so those are some postulates that you're going to have to remember going forward, right? Some of them are kind of obvious, and we already kind of talked about some of these, but make sure you know them, all right? So then let's take a look at how we can figure out whether it's true or false, either using some of those postulates or just kind of drawing our own pictures, right? So we're trying to figure out whether these statements are true or false, right? And if it's false, then you give a counter example to show why it's false. Remember, we just need one counter example to show a statement is false. If it's true, then it's sometimes it's hard to prove or show, but if it's false, it's easy to show just by one counter example. So it says a point can lie on more than two lines. Is that true? A point can lie on more than two lines. So here's a point, right? If you just have one point, right, I can draw a line like this, but is that the only way I can draw a line through that point? Well, I can draw another line like that, right? That's where the two lines intersect at a point. I can draw another line like that. So I can draw infinitely many lines going through that point. So if you just have one point, you could have that, right, lie more than two lines, right? So you have three lines here, and so that is true, right? A point can lie more than two lines. Well, actually, there's an example right here, right? Now, next one is a little bit tricky, but here's a picture here already. Three lines, so here's three lines. Here's the first one, second one, and third one. And you can draw this many different ways, right? But it's saying three lines can intersect at no more than three distinct points. So can you think of other ways to draw this so that you will have three distinct points like this, right? And this one, it says it has no more than three distinct points. So can you draw three lines so that you'll have more than three distinct points of intersection, right? If you can, then this will be false, but that's not going to be possible. So that's also true, right? So the first one is true. The second one is also true, right? And here's just some example picture to kind of demonstrate that. Now the last one, if two lines are coplanar, so it's on the same plane, right? So we got line M, line N on the same plane, then they intersect. Well, obviously that's false because we drew a counter example here. Two lines are on the same plane, but they don't intersect because they're parallel. So that's false. And so that would be a counterexample that you draw to show that statement is false, right? So today, all we're doing is just kind of introducing the idea of a conditional statement in geometry, because a lot of the statements are going to be given to you using if, then. So just like the example, if you are in Mr. Park's geometry class, then you are really smart. You could take that kind of statement and turn it into inverse, converse, or contrapositive and determine whether those statements are true or false by looking at either pictures like this or coming up with a counterexample like this. Okay, so that's all that is today. And so you're just writing a lot of sentences today just to understand the logic and the reasoning and what's called the conditional statement. Okay, all right, thank you. Have a great day.